Hello and welcome to the SAP and Azure Synapse Analytics Integration Series, Part 4. In this session, we will look at how to perform the transformations on the data using the Synapse Spark and how to build machine learning models within the Synapse Spark. We will also load the data from the data lake storage into the Azure Synapse Analytics SQL Dedicated pools as well. Let's get started, folks. Let us first start with reviewing some of the SQL queries where we will analyze the data residing in the data lake storage and the SQL Dedicated pools both. And then we will also deep dive into a Spark job with a predictive modeling example. I have already logged into the Azure portal where I have already launched the Synapse Analytics Studio. From within the studio, I would select the data hub. You can see the workspace with all the associated databases and the linked services as part of the data hub. Underneath the linked services, you can see the blob storage accounts configured into the Synapse Analytics workspace, data lake storage accounts, and any integration datasets you have created as the interim datasets for your pipelines. From within the data lake storage Gen 2 account, I can see my file system, which is SAP Azure Synapse Analytics file system. Once I launch this service, you would find all the containers associated with this, and then you can be able to select the folders and start analyzing the data using the simple SQL scripts. As you can see in this example, I have SAP ASA file system. I got various different folders where I have actually created the data using the Synapse pipelines in the previous session. For example, if I open customer revenue 2 folder, inside the folder, you can see the data in the JSON file format. You can right click on the file format and select new SQL script and select top 100 rows. This would automatically create a new notebook with the sample SQL script, which would allow you to query the data directly from within the file system without writing any single line of code. Again, this is customizable. You can customize the query, add more complex kind of coding as per your requirement. If you carefully observe, it is actually connected to the built-in SQL pools, which is the serverless SQL pools associated with this Azure Synapse Analytics workspace. You can also switch between the dedicated SQL pools or the serverless SQL pools according to your requirement. If I quickly run this query, this would instantly kind of retrieve the data from the file system as if it were a table and display the results on the notebook itself. So that you can update your code, you can review the results, and you can add as much as business logic based on your example. So now let's move on to an example here. So if I'm going into Develop Hub, inside the Develop Hub, I have created quite a few SQL scripts. Let me start by showing you an example for Data Lake Storage SQL Read. In this example, as you can see, select top 100 records. Using the open row set, I'm passing the path for the VBRK file, which is created in the Parquet file format. I'm specifying the Parquet format along with passing some filter condition as well, such as the column name KUNAG is equal to some value. If I run this query, it would instantly kind of bring up the results from the file system. Again, treating the Parquet file as if it were a table. You can also visualize and display the results in the notebook as well. So now let's have a quick look at how to create a new table. So in this example, as you can see, create table dbo.customer total revenue, and I'm passing the column names like customer name, customer ID, and total revenue. which is distributed by a hash distribution replicate mechanism. So there are various distribution schemes within the SQL dedicated pools, such as hash distribution scheme, which allows you to partition and distribute the data across the nodes based upon the hash key, based upon the selected column. Also, one thing you can notice here is instead of the built-in pools, I have actually selected this SAP ASS SQL pool. So this query would run on the SQL dedicated pool, creating a new table called customer total revenue. Again, that lot of these parameters would change depending upon your requirement and your use case. We would like to change the distribution scheme and the partitioning mechanism and so on according to your need. Let me show you another example where I'm aggregating the data coming from the SQL dedicated pools using a simple SQL query. In this example, again, this one is basically creating a new table, altering the schema for the existing table and selecting some data based upon the filter condition. Here is the aggregated SQL query example where I'm selecting top 100 customers based on their total revenue. As you can see, I'm aggregating the data and ordering by the designing as well. If I run this query, it would instantly bring the results in a tabular format. However, I will have the ability to visualize the data in a chart format. You can play with some of the settings here, such as I can select the category column name as customer name, and again, legend as just the customer ID or total revenue. So this would basically allow you to kind of visualize the data and visually interrogate the data as well. So this kind of concludes on how easy it is to work with the data. Either data is in the file system or in operational databases such as Cosmos DB or within the SQL data warehouse, which is SQL dedicated pools itself. While working with the file system, you're actually using the built-in SQL pools, which is serverless SQL pools. While working with the SQL data warehouse, it uses the capacity configured on the SQL data warehouse itself. With that, let's move on to the Spark job and review one of the interesting use case. Let's now review the Spark job where I have created a predictive model using the time series data. I have taken the SGA sales data, which is in the time series format, and used that data in order to build sales forecasting using a linear regression model. Within the Azure Synapse Analytics, I have selected the Develop Hub, and underneath the Develop Hub, you can find the SQL scripts, notebooks, and so on, where under the notebooks, I have selected the linear regression sample, which I have created previously. As you can see, this notebook has been attached to a Spark pool, which is Spark 3.0. In this notebook, I have actually selected, I'm in the first cell, as you can see, I'm reading the data from the SGA sales table. To just give you an example how the sales data would look like, I'm actually collecting the data and printing the data onto the console here. You can see the year and the sales associated with that particular year for the historical sales data. Now that I have created an array using the dataframe.collect method, so again, because the data is quite small, I'm able to now retrieve the data into the driver node using the collect method. If you are dealing with large scale datasets, it is not possible to use the collect method. Then you might run into out of memory sort of issues. So please be aware on what kind of operations you are performing based upon the amount of the data. Then in the next cell, as you can see, I'm actually parallelizing the data in a specific format after creating the data in a labeled point format, which is the format which is specific to libsvm kind of format, which will be used by the machine learning algorithms. Once I create the labeled point with the actual year and the sales associated with each year, and then I create a data frame out of that array. So now that I have created a data frame, now I would, as you can see, the data frame would look something like this. You have the label and the associated features. So label is the one which we are trying to predict, and the features are basically the attributes to which we are predicting that value. Now I'm converting the vector columns to a machine learning specific format using the MLUtil functionality. Once I converted the normal data frame into ML specific data frame, then the next step is I'll create a linear regression instance by invoking new linear regression, and I'm setting some hyperparameters to it, the number of maximum iterations and elastic net param, etc. Once I create the linear regression instance, then I'm actually doing the training of this algorithm using the time series data, which is SGA sales MLDF, using this fit method. So once the training has been done, it creates a model as the output. Now that I have created a linear regression model, I'm just printing the coefficients and intercepts for that model to see how efficiently this model is performing. Once I have printed, then I'm actually printing some of the summary or statistics specific to this linear regression model, as you could see in this notebook. So now that I have printed this summary as well, such as RMSE, root mean squared error, and so on here, now I would then start doing the actual predictions. I'm creating a list with the year 2022, which does not exist as part of our training data. However, now the model will be able to predict what would be the forecasted sales for this particular year using the LR-model.predict of sales forecast list. So now it does the prediction, and then it has forecasted specific value for this given year. Finally, I'm persisting the data as a table so that I can further interrogate the data. So this concludes how easy it is to basically retrieve the data either from the file system like Data Lake Storage, or the SQL Dedicated pools, or even the Cosmos DB, and leverage on the great functionality Spark brings in, such as machine learning kind of capabilities, and build you can do the training of your machine learning model and do the batch predictions natively within the notebooks itself. To summarize, in this session, we have learned how to create the SQL scripts in order to analyze the data residing in the Data Lake Storage or blob storage, or databases such as Cosmos DB, or even the SQL data warehouse itself. Also, we have seen how to use the Spark notebooks in order to build complex machine learning models for the advanced analytics scenarios. In the next session, we will learn about how to create the reports using the Power BI within the Synapse Analytics itself, and also my colleagues would be able to walk through some of the key learnings of the SAP and Azure Synapse Analytics integration journey as well. Please stay tuned, and see you all in the next session, folks. Thank you.